electromagnetic spectrum here. So some of these waves you've already heard of. So hopefully you're familiar with radio waves. So this is basically how we pick up radio signals, so like the AM band and the FM band and so on. Now these would be your longer wavelengths, and they would have shorter frequencies. So if we go to the right here, what you're going to notice is that the frequencies will increase. So we go from the radio waves to things like infrared. And infrared, of course, is the type of radiation that we use in remote controls and so on. So we can't actually see that with the, you can't see any of these other than visible light. So as you move to the right, you're actually getting an increase in your frequency and a decrease in your wavelength. So as these waves get shorter and the frequency increases, they actually get very powerful. So you have visible light right here, which we can see. So after that, we have ultraviolet, and this is where these electromagnetic waves can cause harm. So ultraviolet radiation, of course, is what we get from the sunlight, and this will actually cause your skin some damage, right? And can cause damage to DNA. Of course, people who are exposed to sun are at a risk for developing skin cancer. So, X-rays, of course, are very powerful. We use those to take a look at our bones and so on. So, gamma rays are the most powerful. So, they would have the highest frequency and they would have the shortest wavelength. So if we look at visible light, you may be familiar with the primary colors in art. You have red, yellow, and blue. So in this case, we have something similar to that. We actually have red, green, and blue. So if you're able to look at the picture elements of a television screen or a monitor, you'll be able to see that all colors are actually made up of a combination of these three. So sometimes you might see it's RGB if you are using some sort of connection from a projector to a display. So basically all the light is made up of these three different colors. So your secondary colors are going to be cyan, which is basically a greenish blue, and then magenta, which is this vibrant red color, and then we have yellow. Okay, so if we look at radio waves here, so we're looking at radio waves here. So radio waves are basically some of the longest in terms of wavelength electromagnetic waves that we're going to deal with. So they have a lower frequency and a longer wavelength, the visible light. Okay, so we can use these for everything from radio to television. And as far as I remember, the CN Tower and even the Calgary Tower are used in radio and television transmission. Nowadays, I believe most of that is digital. Okay, so it's hard for people to tune into those things using just radio waves. So we also use these types of waves to basically transmit television signals through satellites. So if we're talking about satellite, we're basically using that for not just communications or entertainment, but also in global positioning. Okay, and of course, microwaves. You're all familiar with using those to heat up food. So, of course, some of the do's and don'ts. Microwaves are reflected by metal. So typically, if we put metallic objects in there, we will get some sparks flying. They will pass through things such as glass, paper, plastic, and similar materials. So these are things that are going to be microwave safe. Although my preference is glass. Microwaves are typically absorbed by food, and usually what happens is they cause the water molecules or the fat molecules to basically rotate and rub up against one another, and this causes friction, and this is what actually heats it up. Okay, but microwaves can also be used for detecting speeding cars, sending telephone communications, satellite and telephone communications, and to treat muscle soreness. Okay, so there's a number of different things that they use microwaves for, which I believe they were originally developed by NASA. So here are some other types of waves. So in this case, it's UV radiation. So basically over 90% of the UV can penetrate through a light cloud. And a lot of the UV radiation is blocked by the ozone layer in the upper atmosphere. Okay, so remember when we're talking about light objects being able to reflect light? Well, they can also reflect electromagnetic radiation. Okay, so in the shade, of course, we can reduce our UV exposure. And depending on where you are, so if you're out skiing, of course, you will get that UV reflected onto you more likely. So sometimes people have to put on extra sunscreen when they go out skiing. Okay, so depending on where you are, that will determine how much UV exposure you have. Okay, so this is about 200 nanometers, and this type of radiation is very energetic, so it can damage your DNA and can damage your skin. Okay, so UV rays can damage the protective coating on your eye, the transparent one that's called the cornea. So, of course, for those of you who wear contact lenses, you can get UV protection on those now. And, of course, glasses, like sunglasses, of course, and even regular prescription glasses will have some UV protection on them. Okay, so infrared radiation. Infrared radiation is usually one of my favorite characters in the movie Predator. So the Predator actually senses its prey by using infrared. And this is the same type of radiation that, as I mentioned, that is used to control remote devices in some cases, like remote controls and so on. Okay. So we can't see it with our eyes, but we can sense it with our skin. And so you can actually have infrared radiation space heaters as well. So X-rays are some of the shorter wavelengths, but they also have very high frequencies. Of course, with this is they are very energetic. Okay, so the radiation that we are exposed to for diagnostic purposes, we often get protection through a lead barrier in some cases, and we also want to limit the amount of radiation we're exposed to because it is so damaging and it has a potential to cause cancer as well. Okay, so gamma rays would be your most powerful. And of course, if you're familiar with the origins of the Hulk, this is basically what created the Hulk. It's the shortest wavelength and also the highest frequency and also the most energetic. And it results from nuclear reactions and it can kill cells. So it is used possibly, it may be used in destroying cancer cells. Okay, so cancer cells can be used, well, basically we can use radiation to destroy those cancer cells in radiation therapy. Okay, so we'll be picking up talking about the eye in the next video, so stay tuned for that one.